Hello everyone and welcome to the next video in the series. This is a technical skills video and the topic for this video is on addition and subtraction of integers. Just a reminder that the set of integers is the set that contains numbers such as -3, -2, -1, 0, 1, 2, 3 and so on, with the sign, positive sign, being optional on the positive side. Now, as far as additions and subtractions go, there are two cases that we will go through. One is the case when the expression that you're dealing with has been simplified. The signs have been simplified so that we just have a chain addition and subtraction. Now, of these, some of them we've seen when we worked with natural numbers. For example, the subtraction or the addition 4 plus 7, where we have positive 4 being added to positive 7, is something that we've seen before with natural numbers. Also, the subtraction 9 minus 3 is something that we have already seen with natural numbers. With the introduction of integers, new cases come up, and there are 4 of these. The first one is when we subtract a larger number, such as 9, from a smaller number, like 4. This kind of a situation we hadn't seen in natural numbers. And the second situation is when we have a negative number and then we add to it a number that's larger than it in size. The third case is when we start with a negative number and we add a number that is smaller than it in size. And the fourth case is when we start with a negative number and then we subtract another number from it. Now, in these cases, in pretty much all of these cases, we can sort of think of additions and subtractions as gains and losses. And this kind of an understanding sort of leads to an efficient way to perform additions and subtractions. Let me give you an example of that. Here we have the problem 4 minus 9, and in order to work this out, let's take a look at the diagram on the right side. 4 plus 9, we can think of this problem as a gain of 4 followed by a loss of 9. And of course we can think of it as a gain of 4 because 4 is indeed positive 4, and we can think of that as we talked about in the first video on integers. We can think of this as 0 plus 4 minus 9. And the proper view is to say that we start with 0 and then we add 4, so we have a gain of 4, as you can see from the arrow here that associates the addition to 4. We have a gain of 4 followed by a loss of 9. So this is the view that we will adopt, and we always see any additions and subtractions as applying to the term that follows, and in this case the terms are just numbers. So we have a gain of 4 followed by a loss of 9. And so with this kind of interpretation, what we'll do is we talk about how we solve each of these 4 scenarios by noting first of all whether the gain is larger than the loss or vice versa, which leads to the sign of the answer as positive or negative. And then we work out the size of the answer. So starting with 4 minus 9, we argue that because we have a small gain followed by a larger loss, we will have a net loss, and therefore the answer will be negative. In terms of the size, because one is gain and the other one is loss, we are interested in the difference between them, and so we can actually do 9 minus 4. And remember in the first video on integers, when I talked about reducing subtractions, we can actually think of this as 4 minus 4 and 9 minus 4, which leads to negative 9 minus 4 or negative 5. So we work out this sign and then we work out the size of the answer. The sign is negative, again because the gain is smaller than the loss, and because we are seeking the difference between the gain and the loss, we subtract 9 minus 4 to get the size of it, which is 5. Okay, the second problem that we had above is negative 5 plus 8. Now this one is a loss of 5 followed by a gain of 8, and because the loss is smaller than the gain, it's going to be a positive answer. We put down the plus, which is of course optional, and in terms of the size of the number, because we have a loss and a gain, we find the difference between them by subtracting the smaller number from the larger one. So we do 8 minus 5, and that gives us 3. We can of course drop the positive sign and just put down 3. Now the third problem above is a loss of 5 followed by a gain of 3, and because the loss is larger than the gain, we will have a negative answer to this. And again, because there are two opposite things happening, to find the size of it, we subtract 3 from 5 to get 2, and the answer becomes negative 2. For the fourth case, we have a loss of 4 followed by a loss of 3, so for sure we're going to have a net loss. And in terms of the size of the loss, we add the two numbers because it's two losses following each other. So we are, in a sense, we are seeking the total loss, and that becomes negative 7. So let's take a quick look at the four cases one more time. In all cases, we compare the size of the gain and the loss to decide whether the answer will be positive or negative. And here we have a gain of 4 followed by a larger loss, so the answer will be negative. Second problem, we have a smaller loss followed by a larger gain, so the answer will be positive. Here we have a large loss followed by a small gain, the answer will be negative. And here we have two losses in a row, and that will result in a net loss. In terms of the size of the number, if one is a gain and one is a loss, we always subtract in the usual order. The number with the larger size minus the smaller one. So here we do 9 minus 4, which is 5, 8 minus 5, which is 3, and 5 minus 3, which is 2. And if it's two losses in a row, then we add the losses to find the total loss. Okay, so the algorithm that we follow in order to add and subtract integers that have been simplified is, number one, work out the sign by comparing the gain and the loss, size of the gain and the size of the loss, and then work out the magnitude. If opposite things are happening, such as gain followed by loss or loss followed by gain, we subtract the numbers, the smaller from the larger. And if two losses are happening in a row, then it will be a net loss, and that would be the sign of it. And then we work out the magnitude, which is the sum total of all the losses. Now, if you have a chain addition subtraction and the expression has been simplified. So as an example of that, we have the problem 3 minus 9 plus 7 minus 4 minus 6 plus 9. And we want to work this out. Now, one thing about these expressions, about extending what I just said to longer expressions like this one, is that it is somewhat inefficient to keep arguing, comparing the size of the gain and the size of the loss, and then arguing whether you should subtract or add. So, for example, here, if I follow the approach that we had above, I can say, starting from the left and going right, I have a gain of 3 followed by a larger loss, so it will be a negative number. The answer will be negative. And also the size of it will be 9 minus 3, which is 6. So I get negative 6. And then I have a loss of 6 followed by a gain of 7. And because the gain is larger, we will have a net gain. So the answer will be positive. And then 7 minus 6 is 1. This is too time consuming. And also, when you have to reason so much, it's just a matter of time before something goes wrong, and then the whole answer will come out wrong. So we are seeking a better way of doing this. And in order to explain how we go about the algorithm that makes it easy to actually work out these kinds of expressions, take a look at the diagram on the right side. Here we have the same problem, but I've used arrows to indicate that we start with a gain of 3, followed by a loss of 9, followed by a gain of 7, a loss of 4, a loss of 6, and a gain of 5. Now the thing is that we can rearrange these kinds of expressions, and we can write them down in any order that we want, so long as, if we have, let's say, a gain of 3 here, we will have a gain of 3 in the paraphrase. And if you have a loss of 4 here, then we have a loss of 4 in the paraphrase, and this means that that the net amount will be the same in the end. The order may be different, but the net amount will be the same, and it should make sense. So if we have a gain of 3 and I want to find out what the net worth or net amount is, a gain of 3, it doesn't matter whether I add it right at the beginning or at the very end or somewhere in the middle. So long as at some point I add the gain of 3, it will be the same kind of net amount that will come out. Same thing with a loss of 9. We can do this earlier, we can do it later, and so long as at some point we subtract 9, the net amount will be the same. Now, why is this helpful? Because what we will do is we will rearrange our numbers and we will write down the gains followed by the sum of the losses. So here I have a gain of 3, you can see it here, followed by a gain of 7, right there, followed by a gain of 5, which is here. So I seek numbers that are being added, such as again 3, 7 is being added, and 5 is being added. So I sort of add up all of my gains, and then I add all of the losses. There is a loss of 9, a loss of 4, and a loss of 6. Now the reason of course I add them is because I want to find the total loss, and then we subtract the total loss, which is the expression inside brackets, from the total gain, which is what we have at the beginning of the expression. The total gain comes to 15, that's 3 plus 7, 10, plus 5, 15. And the total loss comes to 19. That comes from 9 plus 4, 13, and 13 plus 6 is 19. Now you notice that by this kind of a trick, we have actually made the problem much easier to do. If I was going to go from left to right, look at how many subtractions I would have to do. And it is subtraction that's time consuming. Addition is not that difficult, but subtraction, especially if you have to borrow, and keep in mind that the numbers may be larger than what we have here, then it can be pretty time consuming, whereas addition can be done very quickly, especially a bunch of numbers can be added all together in one go. And so what we've done is we've turned the expression that right now has 3 subtractions into one that has only 1 subtraction. And all the argument about the gain and the loss and such, there is only one of it at the very end when we get to this point, 15 minus 19. This is the only time that we have to argue that we have a small gain followed by a large loss, and therefore it will be a net loss, and the size of it will be 4. And so this is much more efficient, which may be why, since we were kids, they taught us that if we have some money and then we spend some of the money on certain items, like let's say I have $3 and $7 and $5, and then I bought something for $9, I bought something else for $4, and a third thing for $6. If I want to find out how much money I have left, then I can add up all the money that I have and subtract all of the expenses. So we add all of our expenses and then subtract that chunk from the total money that we have, and that makes it easier to finish the problem, or actually work out the problem. Now, if you're working with a calculator, then it doesn't matter. You can just type this in the order that you see it, and you get the answer -4. But if you're working the problem by hand, then this approach is much easier. Find all of your gains, add all of your losses, and then subtract the sum of the losses from the sum of the gains. Okay, the next topic is on the addition and subtraction of expressions that are not simplified. And there are 4 of these. It is possible to add a positive number. We may have a situation where we add a negative number, and we might subtract a positive number or subtract a negative number. And in this series, I will always use semantics to explain all of the concepts that we come across, and therefore to explain how we work with such expressions, I will be using semantics. And to begin, when we add a positive number, we can think of this as adding a gain, and that's obviously a gain, and therefore what we can do is we can replace this with simply add 3. Next, when we add a loss, it's like we have a loss, and therefore we subtract 3. If you subtract the gain, again, you have a loss. And that's a loss of 3. And if you subtract the loss, now this one is interesting because it becomes a gain of 3. And that should make sense in some ways. Let's say that you owe your friend $3. So you go to your friend and you pay them $3. And of course your money goes down by 3. Now, if your friend forgives the amount of money that you owe them, so your friend forgives the $3 that you owe them, then your friend gives back the $3 and your money will go up by $3. So for addition and subtraction, and that should be subtraction, not subtraction. Let me just quickly correct this. There we go. For addition and subtraction of integers that in expressions that have not been simplified, the first thing that we do is we use these rules, this understanding that we have about adding or subtracting positive and negative numbers to simplify the expression. And then we follow the rules that we had for evaluating expressions that have been simplified, by finding all of our gains and then adding all of our losses and subtracting the latter from the former. Here is an example of this kind of a situation, this kind of a problem. Number 1, we have 7 minus negative 2 plus positive 4 plus negative 8. And let me just quickly show you the terms in this expression. Of course, 7 is 1. There we go. And negative 2 is 1. Now I hope this jump doesn't keep happening over and over. If so, I will quickly, no, it doesn't happen. Great. Okay, so we have negative 2 and then we have positive 4, which is a term, and then we have negative 8, which is also a term. And there we have it. So we have a gain of 7, and then we subtract negative 2, and then we add positive 4, and then we add negative 8. As usual, additions and subtractions apply to the term that follows them. Okay, so in this case, we'll end up with 7 plus 2. This is a loss. Subtracting a loss is the same as gain, as we mentioned up here. So we get 7 plus 2. And then, of course, adding a gain would be adding 4. And then adding a loss would be subtracting 8 here. Now, normally we need a sort of like a quicker, if you like, way to work out, simplify these expressions. And one common approach is to keep in mind that if you have similar signs following each other like this, adding a gain or subtracting a loss, these ones turn into and if you have different signs, add a loss or subtract a gain, then you will have a loss. So here I can say 7, same signs, that becomes plus 2, same signs, that becomes plus 4, different signs, and that becomes minus 8. Our next line then is 7 plus 2 plus 4 minus 8. Now we add all of our gains. That would be 7 plus 2, 9 plus 4, 13. And then we subtract all the sum of the losses. In this case, there is only 1, 8. And that comes to 14 minus 8, which is, or 13 minus 8, which is 5. A second example, negative 12 minus positive 8 plus negative 4. And again, I think it would be a good idea if I showed you the terms here as well. Negative 12 is one term, and you can think of either only 12 being inside the term or negative 12 being inside the term. And then this is followed by positive 8, which is a term, and this is followed by negative 4, which is the last term in the expression. And so here we have a loss of 12, followed by by subtracting a gain of 8 and then adding a loss of 4. Following the rule that we have up here now, we can say that we have negative 12, and then this becomes a loss of 8, so subtract 8 and then subtract 4. So the next line reads as negative 12 minus 8 minus 4. Now that the expression has been simplified, we argue that we have 3 losses in a row, and therefore there will be a net loss. The answer will be negative. And the size of it is the sum of all the losses. 12 plus 8 is 20, and 20 plus 4 is 24. So we have a net loss of 24. The answer is then negative 24. Okay, everyone, this is the end of the video for addition and subtraction of integers. Thanks as always for watching, and I'll see you next time. Until then, I'll be gone in 3, 2, and 1.